Ladies and gentlemen, welcome. This is 4ST601 Statistics in English and your second seminar. So, in your school email addresses and also in study materials of Microsoft Teams, you can find attached another document in Microsoft Excel with another examples. And today we will continue. We will continue with descriptive statistics. On last seminar, if you remember, we talked about tables, statistical tables, descriptive statistical tables with frequencies, with absolute and relative frequencies, and we also started with some measures. The simplest measures of central tendency. I talked about, for example, median, first and third quartile. Yes. So we talked about dividing statistical sample to groups. Yes, and we also talked about intervals, about interval frequency distribution tables, and today we'll continue. If you check this document, you can see that there is another example based on the data which you already seen. Yes, the data set about our 8 prisoners. Yes, and we have here our 3 variables. Yes, 2 numerical variables and 1 categorical variable. And on the basis of data from our first example, we will specify the following measures of central tendency. Arithmetic mean in a simple and weighted form. After, if you check this table below, interquartile range. Yes, so what we need now? We need our formulas. I already opened the formula sheet here, and arithmetical means, yes, in simple and in the weighted form are written here in the middle. So it will be good to use the whiteboard, and I will solve this for you on the whiteboard. Okay, so if you know, the working place for a teacher is here, and I have written the data set here. So the variable number, yes, number of years spent in jail will be rewritten on the whiteboard. So our values 4, 214, 214. 2354, 2354, yes? You have this document in front of you. Okay, so the simple mean, x with stripe is calculated like, in the numerator there is summation through all E or J, yes? It's not necessary now to denote what is the row and what is the column, because we have only one variable, yes, so there is one column of values, yes. I think that in your formulas from Mr. Hellman is written XE, yes, XE, summation through all E, XE divided by n. We know that we have sample size n equal to 8 prisoners, yes, 8 persons in jail. So if we calculate x with stripe like 4 plus 2 plus 1 plus etc. as the last value is 4, and if you divided this by 8 persons, yes, 6, 7, 11, 13, 16, 21, 25. So numerator is 25, denominator is 8, and if we use the calculator, result should be 25 divided by 8, 3.125. 3.125. So this is the mean calculated in years. Yes, in years. This is the basic unit. Yes, a year. So something more than 3 years is the average length, average time spent in the jail of this statistical sample. Yes. And if you remember the statistical table with frequencies, frequency distribution table, we can calculate this mean on the basis of the weights. Yes, on the basis of the weight. So, do you remember this table where we had x, E or J? Now I will use, for example, J. Yes, the values of this variable. Yes, you can see that we have here values from 1 to 5. Yes, 1, 2, 3, 4, and 5. Yes. Okay, absolute frequencies Nj and relative frequencies Pj. Yes. So we can calculate these frequencies, or you can check the previous seminar. Yes, and rewrite these frequencies here. So I remember that we had here 1 times value 1, 2 times value 2, 1 times value 3, 3 times value 4, and 1 times value 5. If you remember, there can be written the operator of summation. Yes, classical sum. 1 and 2 is 3, and 1 is 4, and 3 is 7, and 1 is 8. Yes. Okay, so absolute frequencies and relative frequencies. 1 divided by 8, yes, you already know what is it, relative frequency. 1 divided by 8, 0.125. 0.125. There is 0.250, yes, again, 0.125, 0.375, and 0.125, yes. Again, the sum of these values must be equal to 1.000, yes. If you don't know how I calculated relative frequencies, Pj, yes, watch the previous seminar, seminar 1, yes, and J divided by N, yes. Okay, so we calculated these frequencies, and now I will delete this variable. I will delete these steps for the calculation of simple arithmetical mean, and I will rewrite on the whiteboard the formula for the calculation of weighted arithmetical mean. X with stripe is calculated like, there is summation, and now Mr. Hellman probably using J, yes, index J, so I will write here through all J, and there is 6J weighted by Nj, yes, and this is divided by summation through all J and J. Okay, so we can calculate it, yes, in nominator. What is in nominator? This is multiplied by this, so 1 times 1 plus 2 times 2 plus 3 times 1 plus 4 times 3 plus 5 times 1. Yes, and this is divided by summation of absolute frequencies. 1 plus 2 plus 1 plus 3 plus 1, 8. Yes, this is your denominator. Okay, so remember, multiplication has bigger priority than summation. Yes, but if you write this on the display of your calculator knows, yes, that multiplication has bigger priority than summation. So 1 plus 4 is 5, plus 3 is 8, plus 12 is 20, plus 5 is 25. Yes? So numerator is still the same, 25, divided by 8, and the mean, the average, must be equal to 3.125. Yes? 3.125 years. Yes, in years. It's measured in years. So this is the weighted mean, calculated on the basis of absolute frequencies, and the same can be done using the formula for relative frequencies. Yes. So if you check the formulas, the PDF file given by Mr. Hellman, you can find here x with stripe. Yes. And this is equal to summation through all j, and there is pj multiplied by xj, or maybe the order is different, xj, pj, but it does not matter. Yes, probably there is written xj, pj. Okay, so now we don't need these frequencies anymore. Yes, I can delete these steps from the whiteboard. Yes, and this formula in absolute frequencies, yes, is equal. Yes, can be denoted like summation through all j, xj, pj, yes, and that's all. So check the following steps, yes. 1 times 0.125 plus 2 times 0.25 plus 3 times 0.125. Yes, and we can continue here, plus 4 times 0.375 plus finally 5 times 0.125. Yes, and that's all. Yes, the variable is weighted by relative frequencies, is weighted by relative numbers. Yes, multiplication has bigger priority than summation, so you can write it directly on the display of your calculator and press enter. So 1 times 0.125 plus 2 times 0.25 plus 3 times 0.125 plus 4 times 0.375 plus 5 times 0.125. The result is equal to 3.125 years. Yeah, so this is the result, and the result is still the same like if we used absolute frequencies. Do you remember how we calculated median and quartiles? The first quartile and the third quartile. We need to have a sorted statistical sample, yes? Sorted, for example, in ascending or descending form, but I prefer ascending, yes? So, we have Excel here, so I will copy these two variables here to next two columns, and I will use the function in Microsoft Excel which is sort and filter, yes? On the home leaf, yes, and the right top corner of the screen, you can find letter A, Z, and the message sort and filter. Yeah? So we'll use this, and after I will again continue on the whiteboard. So if you want, you can do this with me. I am now on my working place. Yes, I selected these two variables. I will use copy and paste. So copy, Ctrl C, and paste, for example, here, Ctrl V. Yes, and I will select this first column with label, yes, also with label. Can you see there is a label, and I have selected everything also with label. And on the top of this screen, you can see I have selected the home leaf, yes, home leaf in Microsoft Excel, and in the right top corner of this screen you can find the sort and filter button, yes, sort and filter button. There is written A, Z, and the message sort and filter. So you can try to click on this button, sort and filter, and on the first position you can find the sort smallest to largest, yes, and this is what we require, yes, sort from smallest to largest. So you can click on this button, and you will see a message here, yes, the message if we want to extend the selection, yes, extend the selection also on this second column, yes. I will use yes, that I want, I require. So please click on this button, and yes, there is a question, what do you want to do? Expand the selection, yes. So click on sort, and you will see sorted statistical sample, yes. You can see that I have here now the sorted statistical sample in ascending form, so I will rewrite these values on the whiteboard, and I will continue with calculation. So the values, sorted values, are written here, and if you remember from previous seminar, the first seminar, yes, the first quartile, yes, x25 was found, yes, between these two values and between these two values, yes, and the third quartile, which is denoted x75, yes, was found between these two values, yes, in the case of variable number of years spent in jail, and between these two values in the case of number of cigarettes smoked per month, yes. Okay, so in the case of the first variable, yes, this quartile was 2 plus 2 divided by 2 equal to 2 years, yes, and in the case of second variable, x25 was 132 plus 2 240, yes, divided by 2, and I don't remember the value, 132 plus 240 divided by 2, 186, yes, 186, okay, and the third quartile, 4 plus 4 divided by 2 is equal to 4, and here x 75, 433 plus 433 divided by 2, and the result is 433, yes, okay, so we have these quartiles. So, interquartile range, yes, are for quartiles, yes. In your formulas, you have written x75 minus x25. So, in the case of this first variable, it will be interquartile range 4 minus 2, yes, this value minus this value interquartile range. So result is 2 years, yes, so again the result is in years. And for the variable number of cigarettes smoked per month, range quartiles, interquartile range, yes, this value 433 minus this value 186, yes, and the result 433 minus 186, 247, 247, yes, so again in basic units, so in cigarettes, yes, so this is interquartile range, and in your formulas, yes, you have also one formula for the range, and this is classical range. Yes, the range, which is calculated very easily, like a difference between maximum and minimum value. Yes, so I will delete this, and we will calculate this classical range, yes, which is calculated like x max minus x min, yes, maximum value minus minimum value in a sorted statistical sample, yes, so for variable number of years, yes, for variable number of years, this will be calculated range. Maximum value is 5 minus minimum value is 1, and the result is 4 years. So you can see it's very easy. And for the variable cigarettes, yes, number of cigarettes. So again, range is calculated like maximum value 589 minus minimum value 40. Yes, and the result should be 549 cigarettes. Yeah, so again in the basic unit. So this is very easy. Okay, I deleted everything else from the whiteboard, and I left here only the variable xj, number of cigarettes smoked per month, in sorted form, but it doesn't matter, yes? And it's possible, yes, to calculate the simple and the weighted arithmetic mean, yes? So if you remember, my formula x with stripe is calculated like summation through all e or j, yes, for example, I can write here xj divided by n. In this situation, yes, the denominator will be 40 plus 132 plus 240 plus, yes, and the last value here, 589, yes. And in denominator, again, we have 8 prisoners, yes? So if you calculate the summation of this column, 40, 132, 240, 247, 346, 433, 433, and 589, nominator is 2460, yes, divided by 8, and the result is simple arithmetical mean, yes, divided by 8, 307.5, yes. So this is the simple mean. We didn't use, yes, we did not use statistical table with simple frequencies, yes. We used interval frequency distribution table with frequencies, yes. Do you remember this table? xj, yes, and we used intervals from 0 to 149, from 150 to 299, from 300 to 449, and from 450 to 599, yes? We use this table. Why? Because it will not have a sense, yes, it will not have a sense if we use this type of table, yes, xj, 40, 132, 240, 247, 346, 433, and 589, and frequencies nj, 1 times, 1 times, 1 times, 1 times, 1 times, 2 times, 1 times, yes. This is not nice, yes, because I have here everything 1 time, so only one exception is this. Yes, so we used intervals, yes, we used intervals, so we had here frequencies nj, yes, and in this interval, inside this interval, yes, we had these 2 values. Inside this interval, we had these 2 values. 3 values were placed inside the third interval, and only this 1 value, yes, is placed inside this interval. Yes? So we did not use this table. We used this table. Yes, and now I have sorted statistical sample to this table, yes. On the basis of this column, I calculated average, the mean, simple arithmetical mean, which was 307.5, yes. Okay, and now I don't have this column anymore, yes, and I have only the table of frequencies, the table of these frequencies, yes, and I would like to use this weighted arithmetical mean, summation through all j, xj weighted by n, j divided by summation through all j and j. Yes. I don't have this column anymore, I have only this table, yes, and I would like to multiply this by this, yes, and create a numerator. Okay. I have here 2 persons, yes, 2 persons. How many cigarettes smoked these 2 persons? I don't have this column anymore. I lost this data set, yes? I have sorted statistical table. And I have here 2 persons smoking cigarette. Or, I don't know, maybe they are non-smokers. There is 0. How many cigarettes these 2 people smoked? 0, 1, 10, 149. We don't know, yes. So there is only one way how to solve this issue. We must go to the middle. Go to the middle of the interval, yes. We must go to the middle of the interval. So there will be calculated new xj, yes. And we will calculate this like 149 divided by 2. And the result, 149 divided by 2 is 74.5. Yes, and now I will use the lower bound, 150 plus this first value, 74.5, yes, and the result plus 150 is 224.5. And again, lower bound 300 plus 74.5, and the result is 374.5. And finally, 450 plus 74.5 is equal to 450 plus 74.5, 524.5. Yes, this is only one way. How can we solve this issue? Yes, because we lost the original data set. Yes, I deleted this column. I know only this, and I know that 3 persons, yes, smoked between 300 and 449 cigarettes. Yes, but I don't know where is it exactly. Yes, so instead of this. Yes, instead of this, we will use these middles, yes, 74.5, 224.5, 374.5, and 524.5, yes? Okay, so I don't need these steps anymore, and we can solve this issue, this formula. So what will be here? Xj, 74.5 weighted by 2 persons plus 224.5 weighted by 2 persons plus 374.5 weighted by 3 persons plus 524.5 weighted by 1 person. Yes, so all of this is nominator. Yes, and this is divided by denominator, summation of nj, so our 8 prisoners, yes? So please give me a few seconds, I will calculate the nominator, yes? 74.5 times 2 plus 224.5 times 2 plus 374.5 times 3 and finally plus 524.5 times 1. Multiplication has bigger priority than summation, so you can write this directly on the display of your calculator and press enter button, yes? And you have nominator, so x with stripe is equal to 2, 2, 4, 6, yes? This is nominator, and denominator is 8. So we will divide this by 8 and the result is 280.75, yes? So this is the result and this is weighted version of the arithmetical mean. And now, we don't have the data here, yes? But according to data here, the original data, we calculated this simple arithmetical mean, yes? And after we reduce this data set to interval frequency distribution table with 4 intervals, yes? We use this formula. Instead of original variable xj, we use only the middles of the intervals, yes? And we reach to different arithmetical mean, yes? You can compare the difference between these mean and these mean. Everything is alright, yes? All calculations are alright, but if we use interval frequency distribution table, every time we lose some information, yes? Some information is lost forever and we are not able to reach the value of arithmetical mean, yes? If we know only this reduced table, so this is a disadvantage. Yeah? This is a disadvantage. We are losing some information, but it's normal. Yes, it's absolutely normal, and everything what we calculated is calculated correctly. We can move to another example. The following table summarizes the results of students from different exercises of statistics during the past semesters. I don't know which one this is, old example. It doesn't include evaluation of excuse, calculate mean, median and model grade for this course. So, mean or average will be calculated on the basis of absolute and relative frequencies. We will use weighted version of arithmetical mean. I will repeat what is the median, yes, and after we will speak about the mode, yes, the mode. What is the model grade? So arithmetic mean, median and mode, all these three statistics are also the measures of central tendency, yes? This is the chapter Descriptive Statistics, Measures of Central Tendency. So we can do this on the whiteboard. So our variable will be xj, and the variable is grade 1, 2, 3 and 4, yes? It's a numerical variable, yes, and we know that grade 1 is the best grade, yes, and grade 4 yes, is wrong because this is failed, yes. Okay, and we know number of observation nj frequencies, yes, absolute frequencies. 13 students received grade 1, 28 students received grade 2, 30 students, yes, have grade 3, and unfortunately 10 students failed, yes. So it's possible to calculate summation through all j, yes, and you have already written in your table that we have here 81 students, yes, 81 students, so it's around four groups, yes, 4 groups per 20 students, and in one group I had, for example, 21 students, yes? Okay, so it's possible to calculate Pj relative frequencies, because I would like to show to you how to solve arithmetic mean, weighted arithmetic mean on the basis of absolute frequencies and also relative frequencies, yes, just for practicing. We know that the mean is calculated like summation through all j, xj weighted by nj divided by summation through all j nj, yes? So it's very easy now, because I have here grade 1 weighted by 13 students plus grade 2 weighted by 28 students plus grade 3 weighted by 30 students plus grade 4 weighted by 10 students, yes? And in denominator, summation of nj is 81 students, yes? So we know this information, so you can write it here, 81. Okay, so again, multiplication has bigger priority than summation, so 1 times 13 plus 2 times 28 plus 3 times 30 plus 4 times 10, yes? The numerator should be 199 divided by 81, and there will be the value x with stripe, the mean average grade, yes? 199 divided by 81. And the result 2.457, yes? So this is the average grade calculated on absolute frequencies, on the basis of absolute frequencies, yes? If you calculate relative frequencies, yes, like 13 divided by 81, 28 divided by 81, 30 divided by 81, 10 divided by 81, yes, you will see here relative numbers, yes, relative numbers. I will use, for example, only 3 decimals, yes, 13 divided by 81, 0.160, 0.160, 28 divided by 81, 0.346, 0.346, 30 divided by 81, 0.370, 0.370, and 10 divided by 81, 0.123, 0.123. Do you remember the formula for relative frequencies, for arithmetic mean based on relative frequencies? It's very easy. I will write it, for example, here. x with stripe is calculated like summation through all j. xj is weighted by pj. Yes, that's all. So variable 1 weighted by 0.16 plus value 2 weighted by 0.346 plus value 3 weighted by 0.37 plus value 4 weighted by 0.123. Yes. Okay, so x with stripe is equal to multiplication has bigger priority than summation, so 1 times 0.16 plus 2 times 0.346 plus 3 times 0.37 plus 4 times 0.123, 2.454. You can see that I have here small mistake, which is because of decimals. Yes, if I use, for example, 6 decimal positions, yes, I will have absolutely same results. If you use Excel, Microsoft Excel, and calculate it in the table in Microsoft Excel, you will see that results is the same. This is only small my mistake because of decimal positions. Okay, so what else? We have to do median and mode. Yes. What is it? Median. Median. x50 with wave. Yes. Median divides the statistical sample to 2 groups. Yes. One group of values is below median, and one group of values is above median. Yes. So we must go to the middle, and we know that the statistical sample can be odd and even. Yes. Last week we analyzed statistical table with 8 prisoners. Yes, and 8 prisoners, it means even statistical sample. Now we are analyzing 81 students. Yes, 81 students. What it means that this is odd sample. So median physically exists. Yes, we will have 40 students below median. There will be median, the student median, and other 40 students above median. Yes? So where is the median? Where is the median? I need a space here. Yes? And we are searching in this sorted statistical sample. Yes, this is sorted sample because there we have the best students, and there we have the students who failed. Yes, so this is already sorted statistical sample. We need cumulate frequencies. Yes, so cumulative, cumul, and j. So where is the student with the number 41? 13 plus 28, yes, 13 plus 28 is equal to 41. 41 plus 30 is equal to 71, and 71 plus 10 is equal to 81. Where is our median, student median? Here. Student median is the last student with grade 2. Yes? Median, student median, has grade 2. So median physically exists. So x50 with length is equal to 2. Yes, this is grade. Grade. And also in the case of mean, yes, this is average grade. Yes, so everything here, everything what we analyzed here is in grade. Yes, grade. Okay, so median is 2, average is almost 2.5, and what is it mode? What is it mode? I will delete this formula and I will delete these steps. Yes. And I will say to you what is the mode. X with hat. Yes, the mode. The mode is the most frequently occurred value in the statistical sample. Most frequently occurred value. Yes, so most frequently occurred value in this sample is grade 3, because grade 3, yes, is reached by 30 students, yes, and this number is the largest. So most frequently occurred value is 3, and 3 is also grade. Yes. So we have here average grade, median grade, and modal grade. Yes. And these 3 statistics are measures of central tendency, and every measure, every statistic give you different information about this statistical sample. So it's good to know all these measures of central tendency. I will do these calculations for you also in Microsoft Excel. Yes. You can see there is the document, so I will sit here and first I will calculate the relative frequencies here. Maybe it will be good to zoom this table. Okay, and right here equal sign this value divided by this denominator. Yes, this value divided by this denominator. And now on your keyboard you can use function 4 button, and you will lock this cell. Yes, so please use function 4, and you will see dollars here. Yes, dollars, and this denominator is locked. And after we can copy these values. So I calculated the first relative frequency, and it's possible to copy these values. If you calculate the summation here, you will see that the result is 1.000 exactly. Yes? We can continue. Multiplication. Xj and nj, and after multiplication xj and pj. Yes, so with absolute and relative frequencies. So you can train at home. There is equal sign multiplication xj times nj. Yes, multiplication of these two cells. And you can copy these formulas. Yes? And after the same xj and pj. Okay, so enter. You can see these results. And here xj multiplied by pj. Yes, relative frequencies. And if you know how looks a formula for weighted mean based on relative frequencies, just simple summation of these values in this column is the result. Yes, So we will do this. Okay, so there are partial results. Yes, and here if you calculate summation, equals sign sum. Summation, that's all the numbers in a range of cells. Yes, summation of these partial results will be 2.457. Yes, 2.457. So the same result like we calculated before. So at all these numbers, yes, and enter. You can see this is the result. Okay, and arithmetic mean. This arithmetic mean, which will be calculated on the basis of absolute frequencies, will be calculated like summation of these values divided by 81. Yes, 81 students. So please, you can write here equal sign sum. Yes, summation. Summation of these four values divided by 81 students. Yes, and that is written in Excel sum through all j, xj and j divided by summation of all and j, and results will be the same. Yeah, the written is equal, of course. Yes, because we calculated this in Excel. Yes, I will decrease the number of decimals, and this is the result. Okay. Median and the mode cannot be calculated here in Excel by function, because we have here frequency distribution table. Yes, so later I will show to you how to calculate median and mode on the basis of data set. Yes, because now we'll have to rewrite these frequencies and these grades as to one column with 81 values. Yes, so I will show this to you, for example, later. Yes, now we will scroll down. We will scroll down on another example. Yes, based on data written in table below, calculate the average age of employees of the company. So there is variable age. Yes, observe variable age, and the employees, yes, are in age between 31 years and 36 years. And we have here cumulative relative frequencies and expressed in percentage. Yes, 20%, 55%, but it's cumulative. Yes, it's cumulative. So again, I will solve this for you on the whiteboard. We must use relative frequencies, but without cumulation. Okay, so on the screen I have a variable xj, 31, 32, 33, 34, 35 and 36 years, and I will directly rewrite cumulative relative frequencies in percentage to relative frequencies pj. Yes. So there was 20%, so there must be relative number 0.2. Yes. Okay. There was cumulative frequency 55%. So 55 minus 20 is 35%. But the relative expression of 35% is 0.35. Yes? And we can continue. Another cumulative frequency, 75. 75 minus 55 is 20. And the 20 in relative expression is 0.2. Yes? Okay. So we can continue. Another cumulative frequency, 80. Yes, 80%. So difference, 80 minus 75 is 5%. And remember, relative expression of 5% is 0.05. Yes, this is 8%. Okay, we can continue. 95 is here, so again we must decumulate this. 85 minus 95 minus 80 is 15. 15% is 0.15. Yes, and finally 100% here. 100 minus 95 is 5%. So again, this value 0.05. Yes. If we calculate the summation through all j, yes, 0.2 plus 0.75 plus 0.2 plus 0.05 plus 0.50 plus 0.05, we must reach value 1.0. Yes, nobody missing in our sample. Yes, and that's all, because now we can use the version of weighted mean, summation through all j, xj weighted by pj, yes, and we have the result. Yes, 31 weighted by 0.2 plus 32 weighted by 0.35 plus 33 weighted by 0.2 plus 34 weighted by 0.05 plus 35 weighted by 0.15 and finally 36 weighted by 0.05. Yes, and again we already said this information that multiplication has bigger priority than summation. So 31 times 0.2 plus 32 weighted by 0.35 plus 33 weighted by 0.2 plus 34 weighted by 0.05 plus 35 weighted by 0.15 plus 36 weighted by 0.05, and average age is 32.75. So this is the average in years. Yes, so this is weighted average calculated on the basis of cumulative relative frequencies. We will continue with another example. We have the following table of absolute frequencies. We don't know what is it our analyzed variable, yes, maybe values. So we can imagine, for example, that the value is size of the display of student's laptop in inches, yes. So 15 inches, 12 inches, 18 inches unknown and 16 inches. Yeah? So size of the display of the computers. And J, number of students, yes, number of users of these LCD displays. So we will calculate missing values if we know that the number of observation, total number of observation is total number of students, yes, using the displays, the laptops, is equal to 30, and total mean, we must know that this is the total weighted mean, yes, is equal to 16 inches. So again, I will solve this for you on the whiteboard manually. Okay, so this is our data set, and firstly it will be good to calculate this unknown n1, yes. N1 will be equal to total number of observation 30 minus everything else what I know, yes, 8 minus 9 minus 5 and minus 2. 30 minus 8 is 22. 22 minus 9 is 13. Minus 5 is 8. And minus 2 is 6. So result is 6 students, yes? So there, instead of N1, should be value 6. Okay, so I will write it here. 6 students have 15 inches size display, yes? And now, we know that this mean, yes, was calculated like x with stripe equal to summation through all j, x, j, n, j, divided by summation through all j, n, j, yes? So, we know that 16 is equal to, and now I will rewrite here this denominator. 15 times 6 plus 12 times 8, yes, plus 18 times 9 plus, I don't know, yes, x4 times 5, so I will write here 5x4 unknown plus, and finally there is 16 times 2, yes? So this is the mean, this is the numerator, and there is denominator, it's divided by summation of nj, 30 students, yes? We can move this denominator here, so on the left side will be 16 times 30, yes. I will move everything from numerator here on the left side, yes. So everything what is not unknown, yes, will be placed on the left side. So 16 times 30 minus, because everything here has plus sign, on the left side will be minus sign. So 15 times 6 minus 12 times 8. 12 times 8 minus 18. 18 times 9. I will leave this here, and finally minus 16 times 2. And this will be equal to 5x4, yes? Okay, so I need more space, so I will use this upper part of the whiteboard. So 16 times 30, 480. 480 minus 15 times 6, 90, minus 12 times 8, 96, 96, minus 18 times 9, 162, 162, minus 16 times 2, 32, this is equal to 5x4. Yes, so 480 minus 90 minus 96 minus 162 minus 32. 100 is on the left side, and this is equal to 5x4. So x4 is equal to 100 divided by 5. Yes, 100 divided by 5. This is equal to 20 inches. So the result x4, this result is 40 inches. Yes, 5 students using 40 inches large screen of the notebook, of the laptop. Yes? Okay, we know very well this data set, yes, our variable number of years spent in jail. And we already calculated arithmetical mean, yes, arithmetical mean, the average number of years spent in jail is 3.125, yes, we already calculated this. At the beginning of today's seminar, I also calculated for you variation range. Variation range, the range, yes, was calculated like maximum value from this statistical sample minus minimum value from this statistical sample. So 5 minus 1, and the result was 4 years. Yes. So today we already touched the measure of variability. Yes, measure of variability, because in measures of variability we have variation range, variance, standard deviation, and also variation coefficient. So since now we will start with measures, with characteristics of variability. So our well-known variable, we know that variation range is for years, and we will calculate variance, standard deviation, and variation coefficient. I will use whiteboard. I will calculate this first variable on the whiteboard, and after I will show to you how to solve this in Microsoft Excel. Okay, so here we have rewritten the values of our observed variable. In your formulas, you can find as x squared the variance, which is calculated like there is summation through all e, xe minus x with stripe squared. What it means? It means squared differences, summation of squared differences between the values of particular variable and arithmetical mean. And this is divided by number of observations. So, what we know, what we already know, we know that x with stripe is equal to 3.125, and n, sample size, is equal to 8 prisoners. Yes? Okay, so this is known. So what we need only, we need to calculate differences, squared differences, and summation, 3 steps. Yes, so xe or xj, yes, it doesn't matter, so I will use xe, and here xe minus x squared, yes, differences between values of our variable and arithmetical mean. So we need to calculate 8 differences. 4 minus 3.125, 2 minus 3.125, 1 minus 3.125, 4 minus 3.125, 2 minus 3.125, 3 minus 3.125, 5 minus 3.125, and finally 4 minus 3.125, yes, differences. Okay, we can use calculator, and I will use only 3 decimals, yes. 4 minus 3.125, 0.875, 0.875, 2 minus 3.125, minus 1.125, 1 minus 3.125, minus 2.125, 4 minus 3.125 is 0.875. That will be minus 1.125, 3 minus 3.125 is minus 0.125. 5 minus 3.125 is 1.875, and finally we already calculated 0.875. Yes, you can try to calculate summation of these differences. And you will see that summation of these differences is 0.000. It means that the differences around the mean are centralized. Yes? These values are centralized around the mean. So if we did not use squares, yes, we'll have 0 in numerator and we will not be able to calculate anything. Yes, so the necessary is to calculate squares of these differences. Yes, so second power will be here, xe minus x with stripe squared. Yes, and I will use squares. 0.82875 squared, 0.766, 1.125 squared, 1.266, 2.125 squared, 4.516, 0.875 squared, 0.766, 0.766. We already calculated this, so there will be 1.266, 0.125 squared is 0.016. 1.875 squared is 3.516, and finally 0.875 is 0.766. And now this can be calculated like summation, so please calculate the sum of these values. 0.766 plus 1.266 plus 4.516 plus 0.766 plus 1.266 plus 0.016 plus 3.516 plus 0.766. So this is numerator as x squared, the variance, is equal to 12.878 divided by n is equal to 8. Yes, divided by 8, and the result is 1.60975. So if you use only 2 decimals, yes, you will see 1.61. Okay, so this is the result, but we have a problem with interpretation of variance, because the variance is in squared units. What is here? There is a variable in years, yes? And what is it squared year? Yes? Year squared, yes? I don't know what is it year squared, yes? I know what is it squared meter. I know what is it squared centimeter, yes? But I don't know what is it squared year. So this is the reason why very often we are not able to interpret this variance, and we are using standard deviation. standard deviation Sx is calculated like square root from the variance Sx squared. So in our situation, this deviation will be square root from 1.60975. Result of this standard deviation, where is the second power here? No, second power, square root from this value, and the result 1.269 years. Yes, and this is deviation, this is standard deviation, very important measure of variability, because its interpretation, yes, its result is in basic units, so in our situation in years, yes, in years. Okay, so variance and standard deviation. Finally, we have to calculate variation coefficient. As variation coefficient, I will delete here some values because I need a space. Variation coefficient is calculated like Vx is equal to standard deviation Sx divided by arithmetical mean. So in our situation, 1.269 will be divided by 3.125, and the result is every time relative number. Yes, result must be relative number. Yes, relative number. So this deviation divided by the mean, 3.125, and the result is 406. So this is the result. In some literature, you can find that this variation coefficient, which is relative measure of variability, yes, it's possible to multiply by 100, and interpretation can be done in percent, yes. So 40.6%, yes. It's also possible to interpret in percentage, yes. We can say from how many percent, yes, from how many percent are our values in the statistical sample different from arithmetic mean, yes, from how many percent the values in our statistical sample differ from arithmetic mean, yes. So we can compare these values. 40 is smaller than 60, 60 is smaller than 80%, etc. Yes, we have comparison, we can compare more statistical samples. The next variable, number of cigarettes smoked per month, yes? And we will do the same like with variable number of years spent in jail, yes? I will recapitulate for you how to solve arithmetical mean, or I will say to you that it's possible to use function average. Yes, equal sign, average, open parenthesis, and select data set. And you will see value 307.5 cigarettes. Am I right? I hope, yes. So, average, double click, you can select this data set. You can close the parenthesis, click on enter, and you will see 307.5, yes? So this is the average. Variation range. Difference between maximum and minimum. I already calculated for you that maximum is 589 and minimum is 40, so result must be 549, yes? Am I right? You can write here equal sign, max, function maximum, yes? Returns the maximum from a range of cells. So max, you can select this data set as minus min. Yes, min is function for calculation of minimum. Yes, so again open parenthesis and select the data set, and you will see that the result must be 549. Yes. Variance. Variance according to our steps. Yes, firstly according to our steps. So I will calculate here differences. Yes, equal sign this value minus the mean, and I used function 4. So what's written here? Yes, the value minus arithmetical mean and dollars, function 4 button, F4 on your keyboard, yes? You must lock the cell, yes, because the mean is still the same. So you can calculate differences. You can calculate differences. You can see 8 differences. And now, how can you calculate a second power? For example, this value times this value one more time. Yes, this is the second power. So I can click on this value times this value one more time. Yes, and you can copy these formulas. Yes, so please do it. You have here the squares. Yes. You can see that it will be much more complicated to do this on the calculator because we have here larger values, yes? We can calculate summation. Summation will be calculated here, equal sign summation, yes? And please calculate the summation of all 8 values, yes? And the summation of sum of squares, yes, will be large because we have here large values, yes. So enter, you can see 222,798. We can verify that I did not lie to you here on the whiteboard, yes. I wrote for you that summation of differences only is 0, yes. You can see that summation of differences only is 0, yes. So the variance is this sum of squares, this last value, divided by 8 prisoners, yes. So this value divided by 8, and this is the result. Do you know how to interpret this? No, yes, it's difficult because variable is number of cigarettes, so this is in squared cigarettes and I don't know what is it. So better is standard deviation, and we already know that standard deviation is square root from the variance. So you can write here equal sign SQRT. SQRT returns the square root of a number, SQRT, and the square root from this variance, SQRT, from this value. And interpretation can be done in basic units, it means in cigarettes. So 166.88, yes, 88. So this is the standard deviation measure of absolute variability. And one measure of relative variability is variation coefficient. So we can calculate the ratio, standard deviation, and arithmetical mean. So please do this. Equal sign. Standard deviation is B126, yes, divided by this value, as B126 divided by B123, and result is 0.543. If you interpret this result in percentage, result is 54.3%. Yes, this is relative expression. So I think that this is enough for today. Okay, so that's all for today. This is the end of our second seminar. Next week we will continue with measures of variability. Yes, today we only touched variation range, variance, standard deviation and variation coefficient. Next week, yes, we will more concentrate of these measures of variability. So that's all for today. I hope that everything is all right. I wish you a good day, and I will see you. I hope that I will see you on the third seminar. So have a nice day and bye bye.